All right, we're going to be dividing radicals. And radicals, if you remember, are square roots or cube roots or fourth roots or fifth roots, okay? I'm going to have a rule written up here, and this can apply to square roots or cube roots or fourth roots or what they're going to call n roots. That means any number of roots, okay?
Oh, okay.
And so if you have a fraction, you can split it and take the nth root of the numerator and the n root of the denominator, okay? So if it was a square root, you could take the square root of the top and separate it. Okay, let me show you what that means. We had the square root. I'm going to start with something a little more simple. Let's go with this one. I'm going to go the square root of 16, big square root of 16 over 9, okay? And this, we can take this and break it down. You don't have to write this part out, but I'm going to write it out. We're going to actually take the square root of 16 over the square root of 9.
4 over 3.
Yes, and so we had 4 over 3, right? We'd be done. We could have just looked at this and took this step out right here and just took the square root of 16 and the square root of 9. Now you know the rule, okay? So we can do that on this one, or on this side. I'm going to do the same thing. I'm just going to move this over.
But there's a problem, because one's cubed and one's not.
Yes, so we don't have a perfect square root on the top, but we have a perfect square root on the bottom, okay? But we can't take the square root of the 3. Can we take the square root of x cubed and have something left over?
We'll have an x left over.
You will have an x, so we'll take an x out and we'll have an x left over.
Oh, so we'll do that like that.
Yeah, so we'll just have this now when we're done.
I like this.
All right, so it's really not going to be too bad. Let's go to another one. Now, the same thing is, we can go the backwards. If I had two things under the square root, I could make them under one square root. And then I could reduce the fraction. How many times does 2 go into 98?
I have no idea. I have no clue.
So if I did 98 over here, and I did a 2, 2 goes into 98.
Would it be 34 times?
How many times does 2 go into 9?
44 times?
4, that's 8, right? 1 and 8. So then I have a 9. It goes in 49
49
times, okay?
Oh, it was close.
So then I will still have the square root of 49. Do you know what the square root of 49 is?
7.
7. So you might not be able to take the square root of 98 or 2, but if you reduced them,
then you
could.
Okay, so I'm allowed to do that.
Yeah, same with this one. I could reduce 15 and 3.
Oh, okay, so
All
then
right.
you'd have 8 square root 5.
8, yes, because these two reduce, become 5.
And then that would be all you could do.
Yes, and that's all you could do. Okay?
Oh, I like this a lot.
All right. This one, now this is a little different. Okay, I wrote it really big. Let's move it down. I can't take the square root of either one of those, and this, I couldn't just cancel those out and make that a square root 9, because it's got a subtract in there. That's the same thing you've been trying to do when we would do the factoring, and you'd get in trouble, right? And so over here we were allowed to just cancel because we've got to multiply, but this one we don't. So we're going to have to do this into pieces. This 3 is being divided. It's divided into both of those. So I'm going to rewrite this as the square root of 48 over the square root of 3 minus the square root of 27 over the square root of 3, because that 3 goes to both. So now I can put this and reduce this one. Does 3 go into 48?
No.
It does.
Oh, well, I mean, like it can, but not like
it does. Let's try it.
Does it really?
1 time, 3, 1, 8, and a 6. So it goes in 16 times.
Oh.
Okay? So this is the square root of 16, and we'll reduce it to 4 in a minute. Does 3 go into 27?
9 times.
9 times.
And that's 3, so then you would have 4 and 3.
Which make?
Minus would be 1.
Yes. Very good. 1. So whenever you got something like this, you're going to put that square root of 3 under each of them, reduce it, and then subtract it. Or add it, depending on what it says to do.
Okay.
Let's do another one. So we've got the same thing.
Oh, so we'll put the 2m under the 32m and under the 6 and 32.
That's right. So we're going to make some smaller there. We're going to do the 32m with the square root under the square root of 2m minus the 6 square root 3, oh, my bad, m to the third over square root of 2m.
Okay.
Technically, I could have done this, though. I could have written one big square root.
Oh,
right?
okay.
So then the 32 and the 2 and the m, what can I do with that?
2 will go into 32. I have no clue. 12 times?
16 times. So the m is going to cancel. I'm going to have the square root of 16 here. Does 2 go into 6?
Yes. 3, and
3 times.
3m squared.
Yes, so I'll have a square root of 3m squared, okay?
And then
Let's reduce this because we have a lot. That's 2.
So then you can do 4 minus 3m squared because you can't reduce the 3m.
Oops. Just fix that. Okay, so I can't. I can't do... I can do the 4 right there.
Right, but you can't do the 3m squared.
This m squared we could.
That's right, so we could do 3.
Yes.
Square root of 3.
Yes, square root of 3. But we have... What about the m? What does it become? Just plain old m.
Oh, okay. So
No, you're right. You're right. They cancel. Right?
Yeah.
So it's plain old m.
You're right.
All right. So I'm going to just make a note of this right here. If you write square root 3m and m square root 3, they're the same. But if you write 3m square root, they're different. Okay? So be careful that you make the square root symbol long enough, or the radical long enough to cover what you really mean. And be careful not to accidentally make that too long when you don't mean the m to be there. That's why I put my m in front, so that I won't accidentally make... If this gets longer, it doesn't matter. The m's in front, and so it can't accidentally get underneath.
Right.
Okay? All right, there we go. All right, we've done a couple things. This one we need to just kind of almost like distribute that 3 to both of them. And this one we just reduce the fractions.
Okay.
Okay? All right?